If this is the first time of visiting this channel, please click on the subscribe button. Do click on the subscribe button and turn on the notification bell so that anytime we bring in new update, you will be able to follow up immediately. Today, we're going to be looking at balancing of chemical equation. Now, before we talk about balancing of chemical equation, what is a chemical equation itself? A chemical equation is simply a shorthand way of representing a chemical reaction. A chemical equation is simply what? A shorthand way of representing a chemical reaction. So, for instance, in a chemical reaction whereby sodium reacts with chlorine to form sodium chloride, which is normally our table salt, we have, write it down first, sodium reacts with chlorine to form sodium chloride. This is the balance equation. Let's do an atom count. Now, on the left hand side, which is the reactant side of this equation, this is what we call the reactant. And whatever we have here constitutes our product. So on the reactant side, we have sodium, but because we have 2 in front of sodium, it means 2 moles of sodium, and that is equivalent to 2 atoms of sodium. While we have chlorine, and we have 2 atoms of chlorine here, we'll write 2. On this side, we have 2 in front of sodium too, so that means we have 2, we'll call it moles, but for now, let's call it 2. Now, on this side, we have 2 times 1, 2. We have 2. So an atom check sees that we have 2 atoms of sodium on the reactant side, which is the left hand side, and 2 atoms of sodium on the right side, which is the product side. 2 atoms of chlorine on the left side, which is the reactant side, and 2 atoms of chlorine on the right side, which is the product side. And by this atom check, we'll see that the equation is balanced. But what happens majorly in most of our problems and chemical ideas in nature, equations are presented as unbalanced equations. And for them to become chemically useful, we have to balance them. For instance, let's say where hydrogen reacts with oxygen to form water, what we have? First of all, write out the formulae of the combining elements to form water. This is the equation. Now, let's do an atom check. On the reactant side, we have hydrogen, 2 atoms of hydrogen. We have oxygen, 2 atoms of oxygen. If you don't understand these cases of atoms and this thing, please go and check our elements, compounds, and mixture. When we discuss molecules in the previous videos, you understand the concept of atomicity better. Now here we have hydrogen with 2 atoms, and then oxygen with 1 atom. Now let's compare these atoms. Remember, the law of conservation of mass said that energy can neither be created nor destroyed. So we can neither create energy nor destroy energy in balancing a chemical equation. By changing these numbers here to balance this equation, you are destroying energy and you'll be creating energy. And the law of conservation says no, neither be created nor what? Be destroyed. Let's do an atom check. We have on this side, we have hydrogen, 2 atoms. On this side, hydrogen, 2 atoms. It's balanced. Here we have oxygen, 2 atoms, but here oxygen, 1 atom. So 2 and 1 are not equal. We'll try to balance this. What do we do? To balance this, if we multiply this by 2, it will be equals to 2. And that will be equals to 2. And that means to effect it here, we'll put it in front. You cannot put a number here. It will change it to hydrogen peroxide, which is a different compound. So you rather put it what? In front. So now, 2 times 2, 2 times 1 for oxygen will give us this 2. But 2 times 2 for hydrogen will give us 4. That means the 2 of hydrogen on this side is no longer balanced. So to make these 2 equal to the 4 on this side, we'll come and multiply here by what? 2. If we multiply that by 2 now, it will be equals to 4. I'll come and write 2 here. You don't come and change here to 4, no. If you change here to 4, it's not even a compound that I know about. So definitely it will be wrong, and you'll be destroying what? Energy, and you'll be creating what? New. You'll be destroying atom and you'll be creating new atoms. So by this, let's do an atom check. Now we have 2 times 2 is 4. 4 over here 2. here times 2 is already equals to 4. So we have 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen, and the equation is what? Balance. Now what happens? Let's look at another example. When nitrogen reacts with hydrogen to form ammonia. Let's do an atom count to know if our equation is balanced or not balanced. We'll do an atom count. Here we have nitrogen, 2 atoms, hydrogen, 2 atoms. Here we have nitrogen, 1 atom, hydrogen, 3 atoms. Basically, all the atoms are not balanced. And so we have to balance them. And we can start balancing for many. How do we know the atoms are not balanced? On this side, we have 2 atoms of nitrogen. Here we have 1 atom of nitrogen. On this side, I have 2 atoms of hydrogen. Here we have 3 atoms of hydrogen. So now, let's start by balancing the hydrogen, the nitrogen. N2, here once, if I multiply here by 2, multiply here by 2 will be equals to what? 2. So I'll come and put 2 here. Now the nitrogen is balanced. So 2 times 1 will give me 2, and here is already 2, so it's balanced. Now, but the hydrogen, 2 times 3 will be 6. But on this side, we have just 2 hydrogen. So what we do to make this hydrogen equals to the 6 on this side? We'll come here and multiply here by 3. Now I will put the 3 here. And if I do that, 3 times 2 will be equals to what? 6. So on the left hand side, I have 6 atoms of hydrogen, 2 times 3, 6 atoms of what? Oxygen. And the equation is what? Balance. So this is how to go about what? Balancing a chemical equation. So please, if you have any question, feel free to drop them in the comment section. I'll definitely attend to each and every question. And please, do not forget to subscribe.